Hey, Mr. Squarepeg, hello, how's it going? It has been a bit since I have done one of these streams, so hopefully everything is still working properly. We'll find out if OBS is updated and crashed everything. Alright, let me just get stuff set up here. Alright, so plan for today. I have been doing some offline work on the multiplayer game, and one of the things I've been wanting to address for a while, not just for that, but for my Game Jam games, is the state machine I've been using is not great. It leaks a lot of details. It's really messy to actually implement and practice. And an idea I've had for a while, there's a lot of different ways to do state machines, but an idea I've had is to have the states be Godot resources. You could also do them as nodes, which I've seen a lot of people do. I've got a few issues with doing it that way. Not that it's a particularly bad way to do it, better than what I'm doing now, but I really want to give the resource approach a try and see if that, we'll just see how well it works. This might be a bust, but we'll try it out. So for some context, let me pull up the state machine I've been using. So generally the way it works is pretty simple. This is a really quick and fast implementation that I came up with during jams. The states themselves are just basic ref counted classes. Ignore the debug name and debug data, that's not really relevant. But we've just got enter, execute, exit, your usual state machine affair. And then each of these functions takes a reference to the state machine itself, so that they can request state changes from the state machine. So using the state design pattern. And then the state machine is dumb simple. It holds a reference to the actor that's using it. And then it has some very, very basic transition logic when you call change state. Now it provides this is honestly one of the biggest issues with this model is the actor. Because these aren't nodes, they're just ref counted classes, they don't have access to the scene tree at all. They're being not nodes or resources, there's no way to really pass these references to, you know, the detection area of an enemy or its weapon system or its navigation system or anything. So the state machine holds a reference to, you know, the enemy that the individual states can access through the state machine that's passed to them. The problem that's created is it creates really, really messy code. So this is one of the state machines from Spectarier, which was a jam game I did back for and name's blanking on me, but did that for a jam last year, or Scream Jam, there we go. So this kind of emphasizes why this is a problem. So this is a traditional red light, green light enemy. When it closes its eyes, you can't move. When it opens its eyes, you can move. So we have some different states here for that, but you can see where it starts to get messy because some of these states are timed. It's supposed to transition after a certain amount of time has passed, but because these are ref counted, not scene tree nodes, they have no way to create timers. So what I did, because it was a time crunch and this is really bad, is the actual enemy, I put a bunch of timers on it, and I'm accessing the private timers through the state, which is just a horrendous mess. And it also means that this state can never be reused with any other enemy. It was a really bad system. And then on top of that, the states were having to call functions and set variables on the enemy. It was a mess. You know, the states may be small, but that's because they've offloaded a lot of their logic into the enemy itself to make this work, which is not good at all. So that's a big part of the motivation for this new design. So the new idea is that instead of having the state be a ref counted, we're going to have this be a resource. Still do enter, execute, exit, still pass the state machine in, but having it be a resource means it can actually export variables and take references to things in the tree. Just gonna say state trees get messy. Yeah, the state machines definitely do. Yeah, I've played around with a few different approaches. So I've got, not in this repo, I have another project that uses behavior trees, not using the plugin Beehive or whatever people call it. I use that for some stuff. Generally, for state machines, I try to keep them very small. Very, very small, because they do explode exponentially, yeah. Generally for this, so where this plays into the multiplayer game is the director. So this thing, let me see if I can pull that code up. Where do I have it? The prototype that I published out on itch for Upsilon uses a director like Left 4 Dead, and it has some very basic states for, you know, if you're not familiar with the Left 4 Dead director, it basically has 4, technically like 6 states where it's ramping up difficulty, hits peak difficulty, allows the difficulty to ramp down naturally, and then deliberately stops spawning enemies for a while. And that's more or less what I did here. And these were a little bit better, but they still had the issue of accessing the actor to get references to data. The model I'm trying to build today is actually based on something from a really old book, Programming Game AI by Design. Yeah, the director's pretty cool. If you want to learn more about that, Valve, it was either a GDC talk or a PowerPoint they did on their own, but there's a PowerPoint presentation out there where they actually talk about how the director works. It's, at least the way they present it, it's a lot simpler than you might think it would be. I can tell you the director in Upsilon, it's probably nowhere near as complex as what they did, but it basically just boils down to a lot of curves. So curves I've drawn in the editor that say, if you have this many enemies and they're in this proximity, increment. Yeah, definitely something on the wiki. There is also a debug mode. If you go into Left 4 Dead, I forget what the command is, but if you press tilde, you can type a command to actually see the internals of the director, or at least most of them. But yeah, all the director does is it just takes into account how close enemies are to the players when they die, and it maps that to a stress amount for each player. And then it says that if the team stress reaches a certain threshold, transition into a different state that increases the spawn rates. And once you've reached an even higher stress threshold, go ahead and say, okay, time to cool off, let the players kill the stragglers, let things naturally die off, and we'll give the players like a random amount of time to relax, and then repeat the cycle. It's a really, really basic state machine. And that's really all, that's at least all mine's doing. And it worked pretty well in the prototype. Now, I do use state machines for other things in the game. I do use them for things like menu systems and that. So I'm not necessarily trying to build just the director's state machine here. But so the pattern I'm looking at doing, the biggest issue I really want to solve is I want to get away from this junk of having the state machine access the actor, because that ties this state specifically to that actor and makes it so you can never reuse it. So if I have 2 different enemies that have a seek state to find the player, I have to write 2 different things, or I have to make sure that I'm always using the same function name. For multiplayer, this is a peer-to-peer game. So the prototype, I'll bring this up. Unfortunately, I did have to take the multiplayer server down. Well, server in quotes, I'll talk about that. But so what I did, because it's peer-to-peer, I looked through some options. NetFox is kind of the de facto option for doing multiplayer. Unfortunately, when you go through their documentation, there is a massive disclaimer that NetFox was not designed for peer-to-peer games, and that it isn't supported. There's a comment on, I think it's a Reddit thread, where the developer says you can hack it to work, but you start messing with some of the internals of NetFox to make that work. So I chose, at least for the prototype, not to use NetFox. I rolled my own thing, but I am using Godot's high-level multiplayer. Because it's peer-to-peer, you don't need an authoritative server. This isn't like a ranked game. This game is meant to be played like Omega Journey from Halo 3, if you're familiar with that, or Left 4 Dead. It's just friends playing together. If somebody wants to cheat, then, you know, don't play with that guy anymore. You know, it's not meant to be anything serious. So there is no authority, or no authoritative server. The host of the game was just the authority. The only server you need to make that happen is what's called a relay server or a NAT punch through. So what happens is your router does not want to let random stuff on the internet talk to your computer. If you have your friend's IP address and you try to hit it and start sending it UDP packets for your multiplayer game, there's a pretty good chance their router is going to say, hell no, I don't know who you are. I don't trust you. You can't just send packets to me. So generally the way home routers work is that some computer on the router connected to it has to send an outgoing packet first, and then the router will remember that you sent a packet out to someone else. And if that person sends a packet back, it assumes that that's a response, and it'll let that traffic happen. The problem is when you have two different players, both behind routers, and you try to send a packet out, but your packet gets blocked by their router, and they try to send a packet to you and it gets blocked by your router, how do you get the two to talk to each other? And then the old way of doing it was you would go into your router's admin menu that most people don't even know it has, and you would configure port forwarding. So you would say, hey, when somebody tries to talk to port 80 on my router, send it to my computer. Most people don't know how to do that. You can't. Some routers do support something called UPnP, where you can, your computer can actually send a request to your router to say, hey, I'm expecting traffic, please open this port for me. But not every router has that enabled because it's kind of a security issue. So there's another way you can get around this. It's called NAT punch through, and it's basically a hack where you trick two routers to let computers behind the routers talk to each other. And essentially the way it works is you just have both computers at the same time start sending UDP packets to each other, because your router doesn't actually know if the packet you sent out ever actually made it. So if you send a packet out and the other person at the same time sends a packet to you, your router might think, oh, that must be the response, I'll let that through. And then same thing on the other side, and if both of you agree and you manage to successfully trick both routers, now the two computers can talk to each other, and the player never needed to know how that happened. The problem with that is that unless you want to synchronize watches with 4 people in your party and say everybody start sending packets right now, that's not a great way of doing it. So what peer-to-peer games typically need is a third-party web server that's going to be sitting somewhere on the internet, and all it does is coordinate that interaction. You're not actually sending game traffic through it. You're just saying, hey, I want to talk to this person, and the other person says, and I want to talk to that person, and then this third-party service will say, on the count of 3, both of you start spamming each other and see if it works. Then if that doesn't work, and sometimes it doesn't, NAT punch through is kind of a hack that I don't know if it's technically even something that's supported or if it's just router manufacturers got lazy. I'm not that familiar with that. The other option is you use something called a relay. So you have a web server. Yes, the one I was using specifically was Node, and I'll talk about that in a second. It's a project that you can just get off the shelf and use with Godot. The other option is a relay. So if NAT punch through fails, what you can do is you can send your packets to a server and say, hey server, I want you to send those packets to this other person. And then that server that's, somewhere up in the cloud or wherever, it's not sitting behind a router that's trying to block traffic. So it doesn't have as much of an issue getting traffic into it as your computer does. And again, at the same time, if the other person says, hey server, I want to send packets to that person, basically, as far as your computer is concerned, you're just sending data to some random web server, and that web server is sending data back to you. What's really happening though is when you send data to the server, it doesn't check it, it doesn't care, it just takes that data and then it immediately forwards it to the other player. And then when that player sends something to you, they actually send it to the server and the server forwards it back. People don't generally like to do that with relay servers though, because that uses a lot of bandwidth. All of the network traffic basically gets doubled. For every packet, you have to both send it up and then send it back down through the server. And that can get very expensive, and you need potentially a lot of ports on that server to handle a lot of players. Not to mention that there's some authentication issues and can people abuse the server, but those are the two mechanisms. The project I used is something called NoRay. It's made by the same person that makes NetFox. And in fact, if you actually look at NetFox, they even have custom integration with NoRay. And what NoRay was, is it's a node, yeah, NAT punch through. More or less, yeah, NAT punch through is the best option. If you can do it, because you also get lower latency with that. So NoRay would help you facilitate that. You stand up a NoRay server in a Docker container somewhere up in the cloud, and both players will try to talk to it. And NoRay had this really basic protocol where it would try to facilitate a NAT punch through by sending like synchronization packets to you and all the peers and say, okay, start now. And if that didn't work, you could ask NoRay to allocate a relay for you instead. So it could fall back to the relay if NAT punch through wasn't working. There are some problems I found with NoRay though. The big one is I personally would not trust it for production. And the reason I say that is it doesn't have any kind of authentication mechanism at all. You can just send whatever packets. If you happen to know the IP address of that NoRay server, you can just send it packets on every port, whoever you are, which isn't good. There's, you know, then even if it's not your game, if some other game supports NoRay, they could just use your server and now you're paying for their multiplayer infrastructure. There's just no mechanism built into it to detect if it's your game or whatever. And, you know, obviously people could always spoof that, but it doesn't even do the bare minimum. And I also noticed, so I had the server up and running. I think it was costing me about $50 a month. And honestly, that was more just because I had to pay a baseline minimum for the hardware I was renting. But the NoRay server would periodically just crash. I had to set it up to auto restart because periodically it would get a weird error about something trying to connect to it and then immediately hanging up. And it wasn't anyone playing the game because I could see the itch analytics that nobody had downloaded the game recently. And none of the people I knew that were doing testing were trying to connect to it. And I think what was happening is that there was some kind of web scraper hitting the NoRay server and confusing it and causing it to lock up. So I don't even believe it was a deliberate attack. I'm a no-name, realistically. So I genuinely just believe that this was some Google web scraper or something just trolling around the web and accidentally broke the NoRay server because it didn't know the right protocol. Now, all of that being said, it's basically moot if you're going to release your game on Steam. If you're going to release your game on Steam, one of the really, really good selling points that I don't think people talk about enough is that Steam has built-in networking for you that is just free to use. You don't owe them any money. It's just the commission Steam takes goes towards that and whatever other services they provide. The downside is to integrate with Steam, you have to use a DLL, like a dynamic link library. Thankfully, there's some good people that have already figured out how to plug that into Godot, and there is a Godot extension for Steamworks, which is Steam's DLL. If you bring that in, it has a custom multiplayer peer specifically for Steam that talks to Steam's networking behind the scenes, and then Steam is handling all of that for you. And Steam will do basically the same thing NoRay does. It will attempt to do NAT punch through, and if NAT punch through doesn't work, it will automatically attempt a relay. And in fact, it's even a little bit nicer because Steam gives the players the option. I don't know if many people know this. A lot of people are not comfortable doing peer-to-peer games because it exchanges your IP address. When you do NAT punch through, you have the other player's IP address on your machine, which that's just the way peer-to-peer works. You have to have it. Steam will try to hide it a little bit by when you try to connect to somebody, you're actually using their Steam ID, not their IP address, but at some fundamental level, your computer's still talking to their IP. When you use a relay server though, you don't know their IP address. You're talking to the web server that's forwarding your traffic. So Steam, if you actually go into your settings, I don't know if it's per game or if it's in your account settings, you can tell Steam to only use the relay. And it will never do NAT punch through. Any game that uses Steam's built-in networking, it will just not use NAT punch through, which isn't great because you're taking on more latency. But if you're really genuinely concerned about other people getting your IP address, that is a setting you can change, which is pretty cool. I didn't know that was an option until I started reading the Steam documentation. But the great thing is, if you use the Godot extension, it happens for you. When I did the prototype, I don't have my tax forms and stuff set up yet to be fully incorporated, so I didn't want to go register as a developer. I'm waiting to get my company and LLC, or all that stuff sorted out so I can go officially register, get the game ID, do all the stuff properly with Steam. But I believe you can actually test it without doing that. Steam does, you don't need to log in to like Steam's backend or anything. The DLL is freely available. The Godot extension is freely available. And there is a test game called Space War, which is in Steam's documentation. And the only thing you need from it is like the Steam game ID or app ID. And if you have that, you can actually just use Steam's networking, with the caveat that you're going to see a crap ton of lobbies from everyone else in the world that's using that Steam ID to test multiplayer. But yeah, that's ultimately what I'm going to be using for the final game. And that's why I shut down the multiplayer server that I was using for the prototype. If you download the prototype now, I've got the host and join boxes grayed out. The code's technically still in there if somebody wanted to hack it away, but I've got it shut down for the moment in favor of Steam, which unfortunately means that the game's going to be specific to Steam. I can't put it on itch as well because it's not going to work that way, but it is one of the nice features. There's actually a lot of stuff Steam gives you. If you're ever curious, the Steamworks documentation is public. You can just go look at it. You can see all kinds of stuff, like what the restrictions on how much you can charge for your game, how often you can put it on sale. You don't need to sign up as a developer to see any of that. It's just freely available. And there's some really neat stuff, like they have automatic filtering of offensive language and things like that. They have a voice chat system. And a lot of that functionality is exposed in the Godot extension. There is another person on YouTube. Their channel is Battery Acid Dev, or BAD. They do a lot of Godot multiplayer work, and they have a couple videos. They're a little bit old. I think some stuff has changed, but for the most part, it's still good info. They have some videos on using that Steam Godot extension and walking, and in fact, they have a whole tutorial series on walking you through building a multiplayer game. Yeah, good, you know them. Yeah, so that's what the final game is going to be using. But on top of that, I'm not going to roll my own protocols or anything like that. I'm just using the prototype that I built was just using Godot's high-level multiplayer. So multiplayer spawner, multiplayer synchronizer, and the RPCs. And it was not too bad to get up and running. I do need to add in some lag compensation. I found that in the prototype, if you got more than a 50 millisecond ping, it kind of felt like you were drunk if you weren't the host trying to play the game. And I'm targeting a max of about 150 ping. Seems to be where a lot of games consider that their cutoff. So I need to do some work on prediction and that, but that's going to be for another time. In fact, I've actually got that on my to-do. Well, I've got that on my to-do list here of things to get done in pre-production. This is 4-player, although technically the way it works in the prototype is there's literally just a constant that says max players. So you could change it, but I'm balancing it for 4. And my goal is that it's a 1 to 4. So I want this to be, I hope this is a common experience, but I like to play a lot of games like Deep Rock Galactic and Back 4 Blood and Left 4 Dead solo sometimes. Sometimes you want to hang out with your friends, go into a random lobby, and sometimes you just want to play the game on your own. So I am balancing it to where you can play it solo or in 4-player. The difference from those games, though, is that I'm not going to have friendly bots help you. So if you don't have 4 players, it's just going to be you, no bots helping. And what I did to balance that in the prototype is I actually had all of my difficulty curves that said spawn this many enemies or whatever. there was two axes, right? One was at this intent or at this stress level, and then the other was for this number of players. So all of my curves could be adjusted per number of players to compensate. So that's what I'm planning on doing. I may need to make some compromises. Some games that do that, when you switch to single player mode, I think Deep Rock does this. They'll sometimes add some kind of bonus to the player to make them a little bit more capable of withstanding the sheer number of enemies. So I may do something like that. I'm not 100% sure yet. It really wasn't, I don't think it was a big problem in the prototype. But that's going to be the plan there. Now, so back to the state machine, which, by the way, great questions. I'm happy to help. If you have any questions about any of this, I am more than willing to share what I've learned and help other people get their stuff up and running, because there is too much stuff to do in game dev to be hoarding knowledge. But getting to the state machine, let's see, where's my Godot? There we go. All right, so we're gonna start out and just stubbing out some stuff here. This is how I like to do my folder structure with a scenes and a scripts for any scripts that aren't really attached to a node. So we'll do state machine, create new script in here, and then we'll also do a separate one for just the state. I am really happy that Godot finally added abstract states a little while back. I come from doing Java programming, and not having interfaces and abstract classes was driving me kind of crazy. Yeah, scenes, scripts, add-ons. I usually do a scenes, a scripts, add-ons if I need it, and then a resources folder. I know Godot's kind of like, yeah, your resources should be in with your scenes, but I find a lot of the times that I will use the same textures and models for like 6 different scenes. So I like to keep those in a separate folder so I don't have to copy them. I don't know if Godot is smart enough to only store one copy if you have it multiple times in your directory. But I don't think we'll need too many resources here. I might pull in some placeholder assets once we get the machine up and running. And just have that be abstract. Hopefully Godot 4.6 behaves. I just upgraded to it yesterday, and I've found so far that it's a little bit unstable. It's, you know, it's always crashed every now and then. You'll open a menu or hover a mouse over something and you'll get a random crash, but it feels like 4.6 is maybe a little bit buggy at the moment. So hopefully it doesn't crash on us. Thankfully Godot's pretty good about saving, so it shouldn't be a huge issue. But yeah, I like it as well. I forget what it was. I was watching the release notes every single week, and then I forgot what it was I was waiting for that was going to come out. I was actually not going to even leave pre-production on this game until 4.6 was out, because there was something I was waiting on. Yeah, I'm sure they'll get it fixed pretty soon. They've been really great about that. I started out with 3.5, I think, is the first version I played with, and it is a massive improvement between then and now. 4 was just such a great update, and 4.5 is really good as well. Especially when one of the big things that drove me crazy for a while was that there was no support for what do you call it? First-person shooters, really. And what I mean by that is the whole issue of your gun phasing through walls. There was a bunch of hacky ways you could do it prior to 4.5 or 4.4, and they added in, I think it was 4.5, they added another setting to the standard material shader that lets you force override the depth buffer for that material, which basically lets you always render something on top of everything else, or always behind something if you really wanted to do that, which allows you to do a first-person gun that doesn't phase through the wall. I was so happy that they finally added that. It made things so much easier. All right, I do not have my state machine class yet, so over here, add that. And I think for the most part, I am just going to borrow the code. There we go. I'm just going to borrow the code from my old state machine, and we'll start with that. So let me just copy that here. There's not really a lot to copy. The other thing I'm hoping to do with this, the big thing is honestly just making this, oh, yeah, no, I do want this to be a node. Although state, I said I want it to be a resource. The other thing that I would like to do is make this more compatible with multiplayer to where I can do rollback. So actually, that's the other thing I forgot to mention, how I was going to solve the having to reference the actor problem. What I plan on doing, I'm borrowing something that's usually reserved for behavior trees, but there is a concept of a blackboard in a behavior tree, which is basically like a dictionary where you can just write whatever values you want, or the states, I should say, can write values to that dictionary, and then they can come back later, and even different states can read values. So you would say, you know, the big example that you see a lot is target. So if you have target selection and you don't have the target selector as a separate node, it's something that happens as part of your state or your behavior tree nodes, you would write to the blackboard target equals player 1 2 3 4, and then in a different node that is trying to say dodge the player or dodge the target, you know, if you think about enemies that strafe around you or whatever, it could also read the blackboard and get the target. And then the other thing you can do with a blackboard is you can write outputs to it. So you can write target position or, you know, go here or whatever from your state, write it to the blackboard, and then the node that's using the state machine can read the blackboard and look for that value. That's the approach I'm planning on taking with this. I'm not going to go quite as simple as just using, you know, a string dictionary to set stuff. I plan on doing something with like handles so that it's a little more controlled, but that way there is no access to the actor. The state does not know what kind of entity you put it on. It's just writing stuff to the blackboard and reading stuff from the blackboard. And if the agent, you know, the enemy cares, it will read that value. And if it doesn't care, it won't. And ideally you write your blackboard in a way that if you try to read a value that doesn't exist, it just returns some default value or something that the state knows what to do with. You know, there's no helping misconfigurations. But that also means that you don't have to wire up all your states to random nodes in your agent. Because you might have one node that uses line of sight to detect if they can see the player. And you may have another agent that uses an area to detect if they can see the player. And you don't want to have to write your state for detecting if they can see the player to handle both circumstances. Instead, you just write, you have your agent write to the blackboard, can see player, or this is the player I can see, and then just have your state read that, and it never has to care. So it's getting a little bit wild where you're just passing data back and forth through a dictionary. But the reason I think this isn't too bad of an idea is it's the same way animation trees work in Godot. So when you create a animation tree, and we add this here, and it's probably going to be mad at me. Let me add an animation player so it's got something to link to. Add that. So in this animation tree, we come in here and we give it a new blend tree. And you've got, we'll say a transition node. And we throw this in here just to, as an example. This is kind of the way I intend on the system working. Now, I'm not going to go make the UI. It's not worth it right now. But this thing takes some basic settings that you can configure over here. But how do you actually pass data to it? How do you tell it to transition to what? And the answer is it's in the player. The animation player itself, if we go to the documentation, you use, oh, it's not in here. Dang. Okay, let me switch to the Godot documentation and show this. But the idea is that the animation player basically has a dictionary of values that it's just passing that whole dictionary to every one of the nodes in the animation tree, and if they care, they read a value from it, and if they don't, they don't. So it's actually the exact same paradigm they use, and that's part of the reason why I wanted to try this out. So let me see, Godot animation tree. Because actually that was part of why I haven't streamed in a bit is I've been doing a lot of research into things like animation trees that I've never played with before, but I'm gonna need to really have the game be polished. So if we come here, so we get some examples here, and here we go. So on your animation tree, you just set these parameters that the nodes will use. So parameters one shot, which is this node here, request. Now I'm not going to do it exactly that way with the whole paths and everything. I'm just going to do key value pairs basically. But it's the exact same model. So these variables are not stored in this node at all. They're just stored in a dictionary, or technically the properties of the animation tree. So that's the paradigm I'm going for with this one. So plan is we're gonna write up the basics, and I'm gonna try to throw together a couple of use cases, maybe copy a bare bones director over. I've also got an old like tag game that I made to test Godot's navigation. We might copy that over. I just want to actually see it in action, because this is one of those things where I can think about it in my head. I know it's possible to code it, but when I actually start using it, am I going to find out, oh crap, this thing is a really bad idea because the workflow to actually integrate with it is dumb. I can't reason about that in my head. I have to actually see it happen. So we've got change state. This is going to change as well. So in the old system, when you wanted to change a state, you actually had to make a new instance of that state and pass it to the state machine, which is really dumb. It meant that, for one, you could never change which state went where. And two, it's not great for memory to be constantly constructing these new state objects all the time, especially if you have, 60 enemies in the scene and they're all constantly changing state. That's probably not going to be great on Godot's memory management with it trying to clean up memory like that. So the idea with the new system is that when the state wants to change, it's going to pass, I'm not 100% sure yet what it's going to be, but either some kind of ID or handle to the state it wants to switch to. And you'll configure that in the resource itself. So along those lines, I'm just going to leave this here just so we don't get any compiler errors or parser errors. So one of the things I need is, well, I guess we don't need to export a name just yet. So I do need some kind of ID. I guess I do need to figure out the ID now. So I've thought about it a couple different ways. The first naive idea I had was, why don't I just take a reference to the state you want to switch to? And then it occurred to me that if you have state A can switch to state B and state B can switch to state A, you're going to get a cyclic dependency. And I think Godot can handle that now because resources are technically saved in a database and they're only one of them. I don't really want to test my luck on that. So I'm going to pull the ID out as a separate object. So what I'm going to do here is actually make a new script, and we're going to call this like state handle. And this is one thing I'm a little bit worried about, is just the overhead, how many classes and resources and things I'm going to have to make to wire this up. But that's part of the fun in trying. We'll figure out all the ways this doesn't work. If this doesn't work, I'll probably just use the node approach. So we will call this a state handle. And literally, I think all it's going to be is just an ID. So we will just do that. What did I forgot var. There we go. All right. So now on the abstract state, we will export a reference to the state handle, or we'll just call it handle. All right. So now if you want to actually create one, you have to give it the handle. And then in the state machine, you will have to pass it a handle to switch, which means I am going to need a set of states here. In fact, actually, I might do this as a dictionary instead of putting the handle here. We'll see. Okay, so we'll do export var. Actually, move this up here. We'll do a states dictionary, and we will do a state handle and then an abstract state. All right, so let me come over here and actually add an instance of this thing and start seeing what it looks like. So get rid of these. All right. Yep. Okay, that looks fine. So we can do a new state handle and call this like idle. And I don't have any states yet, but so then in here, whenever you want to switch, you take the handle, and we'll take the state handle. I'm gonna have to have some logic to deal with the fact of what happens if for some reason you pass a handle that's not compatible, but whatever. And the whole point of doing it this way is that we're still using the state design pattern, where the state itself is going to make a decision in its enter, execute, or exit function when to change. But it's just, instead of hard coding change to this, we're going to expose a variable on it that says on death change to this handle, and that way we can wire up the handles here. So it's kind of a hybrid of a traditional state machine where you have like a routing grid on the machine itself that says go here, go there, which is, you know, the way the animation tree works. And the state design pattern where the states own the logic. We've just basically made it so they can be rewired. And because these are resources, you can just drag and copy them between them. So I can put here, this is this thing's handle, and then on whatever other resource that, you know, in fact, I'll as soon as I get this compiling real quick here, I'll show that. But first things first, if states.has handle, does that check the key or the value? Yes, okay, value, or the key. We will get the key. Okay, so now let me make a quick test here. So we will just do a new folder for, I don't know, we'll just call it enemy. And we'll just start making some quick states in here. So I'll create a resource in here, and we'll call it, we'll do an abstract. Where is my state? Hope if I can spell. Okay, what did I do? Oh, right, because it's abstract. Okay, let me create a new script, and we will do abstract state, and we will just call this idle state. I guess ideally these should probably be created invalid inherit. What? Well, that's a new one. Really? Huh, okay, well, I will just make the script and then I'll set it myself. That seems like that might be a bug. Or I don't know why, but I can code really fast in Godot. I've done 48-hour game jams. I've pulled off nigh impossible, but the moment I turn on the streaming software, I am incompetent. Okay, so we'll call this just idle. I can spell idle state. And we will just copy these over. Actually, I remember now, I did not want to do these as abstract because I don't want to have to re-implement each one. We'll just put a pass in each one of these in case a lot of my states usually don't end up needing exit. In fact, that's pretty rare for them. So we will do, well, I don't even need to bother with that, just for the example. So we'll export and we'll say var enemy found state, and this will take a state handle. And the way this is intended to work is that in my enter, or sorry, execute, you would do or I should probably do that. You would do something like this: if state machine dot blackboard dot get I don't know, has enemy equal, and then you would do state machine dot, or can see enemy or something like that. You would do state machine dot change state enemy found state. That's the way this is intended to work. So the state itself is still responsible for deciding when it switches. It's just, and it declares what things it might switch to, but you get to wire up and tell it in code where. So if I come into the state machine now, and I do, new state handle, we call this idle, and then we do that's interesting. Oh yeah, idle state, misread that. So now you can wire it up here and say which thing you want to go to. So if I have another state, and we'll just duplicate this and we'll call it, I don't know, combat state. So we have combat state, and we'll say enemy lost. And we'll say if not, we can do enemy lost state. Now this maybe isn't the best way to offload that much functionality into the Blackboard, but I can come back here. I keep forgetting to save what I already did. So we call that idle, and then we do our idle state, and then we can pass in a new state handle, and this one's combat. Okay, so okay, already I'm seeing a little bit of a problem, and that's that the resource editor does not handle nesting super great. That's getting a little bit confusing to look at. Okay, so new key, new value is an idle state. Enemy found. Oh, right, yes. Oh, that's right. I said I didn't want this here anymore. That's why that's throwing me. There we go. So we add that. So now this has the idle state that says it's going to switch to the state with the handle of combat. So then we would come in here and we would actually take this combat handle, which instead of doing this inline, I might actually save these. But now we have that, and we can do the combat state, and then we can copy the handle for the idle state. Maybe last, what did I copy here? Oh, I copied the state. That's combat. Where did that go? Idle state. Oh, there we go. No. Huh. Okay. Yeah, this is a little bit problematic already. I'm seeing just the workflow of trying to wire this up is a little bit difficult to find what I'm looking for. So that's the... Oh, there we go. There we go. Okay. So how do I copy the key then? How do you... Oh, that's interesting. So how... All right. All right. We're going to stop that. And we're going to do this the way I was planning on doing it originally. Let's reset all that. We're just going to clear all these. And we're going to save this to the file system. So, yeah, okay. Already starting to see holes in this pattern. It is the same workflow as what the animation player is essentially doing, but they went to the trouble of making a whole UI for this, which I guess I could do, but I've never done that, and I imagine that any kind of graph UI like that's probably going to be a little bit of a pain. But we'll push through a little bit further and just see where this goes. The idea, though, is that you'd only have to create this stuff once, so it's not the end of the world. But we call that idle, and then we duplicate that, and now we have a combat handle. They'd probably call these combat state handle or something, but whatever. And we type combat in there. And then now on our state machine, we can do the idle handle, and then we do a new idle state, and then we quick load that and do combat. Yeah, okay, that's a lot better. So now here we can quick load the combat handle. We can make a new combat state and load idle. There we go. All right, there's the vision. So that is the way to go if you go this route. So what's going on here is that we've got a handle assigned to this idle state, and the idle state can switch to the combat handle instead. And then the combat handle can switch back to the idle handle. So now we don't have a cyclic dependency because the handle isn't actually part of the state itself. It's a separate thing entirely. So that I think there is an option where you can do it using resource ID instead, which would be built into Godot. I don't necessarily want to go down that path, but okay. So we've got that, and we've got the blackboard. I guess I should probably expose that, but so the state handle is good. I could potentially put a human readable string in there for debugging, but now back here to change state. I think all of this should be fine. I haven't run into any major issues with the way my update code works. And get current state. I don't really need that right now, not for testing. Okay, so then all we need is the blackboard, and I am actually going to make that a separate class entirely. So we will do a new script, and we'll also do ref counted here. Now this one we will do ref counted because it's not actually going to be a resource or a node. It's just part of the state machine, and we'll call this just state machine blackboard. Every time I always hit that parentheses. Really original naming here today. Okay, so we'll do a private dictionary, and we'll call this I don't know, values, or let's call it data. Do dictionary, and I am going to want another value, but I'll just type string in there for the moment, and we'll do a variant as the type for the moment, because there's really no reason to restrict what you can save in here. Well, I suppose so. One of the other reasons I like the blackboard approach is that you could plug the blackboard into a synchronizer and synchronize that over the network, and that means that all of the state data, because the idea here is that these states like idle and combat, these would not have any private data on them at all. They have their configuration with the export, but then if they need to save a variable for the next execute tick, they would save it to the blackboard. So these things don't save anything on their own, which I found is a pretty good practice for resources, because you can get really nasty bugs if you start saving runtime state into a resource, because of the way they're shared. So the nice thing is, though, if every state is storing all of its data into the blackboard, then all you have to do for network synchronization is synchronize the handle of the state and then the contents of the blackboard, and you can synchronize that to every peer, and you just synchronize the entire state machine in one go. Basically, you don't need to add any special synchronization logic to each of the states. You don't need to worry about fast forwarding the states or anything like that. You can just force reset everything. Now, it doesn't account for rollback and network time and all the other really nasty things you have to deal with, but it's a start in terms of making it. The other nice thing is debugging. All of the states are storing all their data in one spot. So if I want to have a debug overlay, all I have to do is just get the contents of the blackboard and throw that up on screen, and then the handle of the state that's running. I don't have to code a logic into each state to print something onto the screen, or I don't need to go try and read variables from each state to get their data. So again, just that's one of the other things that kind of goes into this. Okay, so I said I didn't necessarily want to use a string for the dictionary or for the blackboard. The only reason I don't like using strings for stuff like this is it's easy to typo them. Where possible, I will usually just make a resource, just like I did with handle. If there's a string that I plan on reusing anywhere in the UI, I'm gonna or anywhere in the editor, I'm going to make a hand or a resource for that, so that there's only ever one copy of that string, and I'm not going to typo it somewhere, because I have to actually drag the resource in instead. So we will do the same thing here. We will call that, I don't know, probably a Blackboard key. In fact, actually, I think I'm just going to put that in the Blackboard itself. So we'll do class Blackboard key extends resource. Usually I don't like doing this because it gets some... Oh, that is definitely not right. There we go. This can get a little annoying to deal with because you have to reference this through that, but I don't think it's going to be that big of a deal because it's not really going to ever be used in code. And then all we're going to do here is just do an export var key string equals whatever. I could add a type here as well and have this do type checking. So if you try to read a value from the Blackboard and it's an integer when you were expecting an object, it could detect that, but I don't think I need to do that right now. So all I'm going to do is first add a clear function. So we'll do clear key. And we will take in one of these Blackboard keys. Also put up there. And this way, if a state wants to fully reset itself when it enters or something like that, it can do that. So we'll just say if, or actually, I think you can just do data erase. I don't even, let me double check. I think you can do that. Yeah, you can do that. Cool. All right, so we don't even need a conditional there. And then we will do a set key, or just call it set, or let me double check. I think set is already taken in object, if I recall correct. Yes, it is. I have to call it something else. We'll call it, I don't know, set value, or you know what, I'll call it put instead. Forget what language, programming language uses put, but we'll do that. And then we'll, same thing, we'll take in a key and we will take in a variant for the value. All right, and just gonna do that. We'll just do data dot set key and value. Probably should have some logic here to make sure that the key isn't null or something like that, but whatever. This is a prototype. We'll deal with that later. And then get, we'll do that. And now here I am going to do something. I'm going to have a default value. And that way, if it doesn't exist, it's going to be pretty common that if something doesn't exist, you want to default to some reasonable number or something. So we'll add that in, just set it to null. And we will say, I want to say you can just call get on this without checking. But if I recall correctly, I think if you do that, it does throw a warning. Yeah, well, we'll try it. But yes, it does work that way. So we'll just do return that and default value. And what did I do wrong? Oh, yeah. Get or else. We'll call it that. Use some Java terms there. And that should be it for the Blackboard. So now they should be able to read and write to it. And now this is the, just like with the handles, the idea here is that the Blackboard handles or Blackboard keys would also be passed in as variables. And that way, if you want two states to share the same variable, like target, like I talked about earlier, you make one key and then you give that key to both states, and now you're guaranteed to know they're both going to call it. This way you don't have to worry about knowing, oh, well, this state stores its data in target dot, I don't know, player, and the other one just calls it target or objective or something. This way you can reuse it. And it also means that you can have a little bit better chance at making sure there's no overlap since you're explicitly saving these handles. So we'll do the same thing here. We'll do a var and we'll say enemy blackboard key, and we will call that. No, yeah. See, this is exactly what I was worried about. That's annoying. Okay, I'm gonna move that into its own class because I don't like having to do that. All right, so we'll come down here, and we will just do a new script. We'll make that a resource, and we will call that a blackboard key. Oh, and get rid of that. And get rid of that. There we go. All right, are you happy now? Yes, you're happy now. All right, so we can come back here to this, I guess that was combat state. Get rid of that. That's much better. Okay, so now we just reference that, and this is also get or else. And also occurs to me I need to actually expose that, but the name of the game here is data driven. Make all this stuff data driven. Keep the logic in the state where it belongs, but all the data that connects things together, keep that configurable so I can reuse this and compost it as much as possible. And the overhead is a little bit rough, not gonna lie, and I think that's probably gonna be, I think at the end of this, the big takeaway is that the node based approach, where you do your states as nodes, that like a lot of people do, is likely got a lot less setup. I haven't tried to implement it myself, but I'm guessing it's going to be the case because you can use things like node paths, and also reference the nodes to each other without causing cyclic dependencies. Let's see, where is my, oh, there's state machine. All right, so let's add the blackboard, and we will just, in fact, for this, I think I will do a property. And the reason I want to do a property is so that if you attempt to set it, nothing happens. Because I don't want you to be able to set that to null and break everything, but I also don't want to write a setter for it. I think I can just omit get, that will just work. Okay, that should be good then, I believe. Although on this state machine here, I do need to now fill in the additional information on the combat state here. So in here, I can do a new resource, and we will call that a blackboard key, and we'll call it like, I don't know. What did I call that? Did I call it enemy? What did I call that? Was that, yeah, okay, enemy. All right, so we will call that enemy visibility. Okay, and then we'll just say can see enemy. All right, and I think that's the only one I need. So then I'll just plug that in to the combat state, and then I need to do the same thing in the idle state. And also it occurs to me, I actually want that to be false. So let me fix that in the other one. And fix that here too. And of course that's going to unset that. And there we go. Okay, so now these two states should be fully wired up, and they both have access to the blackboard. So let's go and just quickly test this. We'll just do 3D. We'll call this enemy, and we'll cut the state machine and move it over here. What did I just do? There we go. Oh, what did I break? Identify our next state not declared. Ah, yeah, that would do it. Okay, so now on enemy, we'll just save that. Oh, yeah, I already got a folder for it. That's perfect. Okay. And we will instantiate an enemy over here. Now, I actually need to plug the state machine into something. There's a reason on the state machine I did not just use the process or process physics method. And that's what I was saying earlier, making this network compatible. I like having the option of choosing how often the state machine updates. Now, something I didn't do here that I probably should do in the director code, I copied, this is actually an older version of my state machine that I started with. The version that Project Upsilon uses actually passes in a delta time here, which is used for timers in some of the states. So I am missing that. But the nice thing about this is if you're using something like NetFox, NetFox has a network tick that you have to hook into. You're not supposed to calculate your logic. Any logic that needs to be network synchronized with NetFox, you're not supposed to do it in process or process physics, because there is no way to roll those back. So if your peer gets too far ahead or too far behind, you can't fix the ticks and get it back into sync if you're using process physics. There's no way in Godot to force a physics processing step, or to force, well, I think there is a way actually to force a normal processing step, but you can't force a physics processing step. So NetFox exposes a signal called network tick, or I think it might even just be a regular callback, but you do all of your logic that needs to be network synchronized in there. So having this not tied to process or process physics means that I can update this whenever is necessary. And if I want to have this state machine be network synchronized, even though I'm not using NetFox, I may use a similar model. I can choose where I want to call it. Now, for convenience sake, it might not be a bad idea in the full version to add an export variable to enable running in the process or in the process physics. Similar to how actually down here you have process mode. That it might not be a bad idea to have something like that where you can choose between manual, process, and physics. But for the moment, we're just testing this idea out. We'll just chuck it in here. So in here, we will get a reference to our state machine. Really wish whenever you I wish in Godot that when you do the control drag, it would put the underscore at the start, because there's almost never a time where I want this to be public for my onReady variable. So I really wish that you could configure that. But so we will do in ready, we're going to start the state machine, which occurs to me I don't really have a great way of doing that at the moment. But we will call change state, and we will come back to that in a second. And down here in execute or process, I'm already forgetting the names of these, I will plug in state machine.update. All right, now it occurs to me on this state machine, I need some way of defining what is the initial state. So I'm probably just going to do that with another export. Or I could even just have it take the first one that's in the dictionary. I forget, are these sorted by default? I don't know that they are. Well, okay, doesn't matter for now. I will just pull in a reference to the idle handle. And we'll do that. We'll also do state handle, and we will just do that. There we go. All right, so that's theoretically all it takes to wire it up. And now if I want to detect the player, well, I guess this is the enemy, so it's detecting something else. We'll just say if it detects anything. So in fact, we're going to change this. Well, I don't need to necessarily change it. I can just move this manually. So I'm going to add a area node onto here, and add a collision shape, and we'll do a cylinder. Now, ideally, this would be a component. This would be something like a detector component or a sensor component. I've done that a lot. Games like Maximum Voltage, that's how I did that. And in fact, actually, potentially the nice thing is some of the components you may even be able to, if you get crazy with it, if you write a reusable detector component, you could potentially have that detector just write directly to a State Machine Blackboard, so you don't even have to wire it up in code. You could make that configurable. Like you mentioned earlier, composition. So if you've got individual components like that that can talk to each other, and save yourself having to write code to wire them up, that can be a big help. But for this, the idea is I'm just going to put a cylinder around these guys, and we'll just drop a couple of them into the scene, or we'll drop something into the scene that it can detect. And there's no collider on this, so we don't really need to worry about what it's doing. That looks fine. And then we'll just add a mesh instance here just so we can see it move around. We'll do a capsule mesh. And how tall is that? 2 meters. Let's bring that up 1 meter. Oh, that was rotation. There we go. Actually, we'll bring this up 1 meter as well. There we go. Okay. So there's our enemy with our state machine all wired up. So now I will just grab a reference to my area. We'll just chuck that in here as well. And we will just say area dot body entered dot connect on body entered. And then we'll need one for body exited. This is the kind of thing that you can set up with a component. So I had in another project, actually in quite a few of my projects, I have a component that pre-connects to these signals and just emits one signal whenever something happens, that outputs like a state change, which is a lot nicer to work with. Okay, so we've got that. We'll come down here, do that. And this is going to be where we're writing to the Blackboard, which again, we could do this a different way that doesn't require the agent to do this manually, but actually, I think that's a node 3D. Let me double check that. I believe, yes, that's a node 3D. That's expecting. Okay, so then what we're going to do here is we're going to do state machine dot Blackboard, and we are going to do put, and we will grab a handle to the enemy visibility thing, and we would call that a Blackboard key. And we will just say true. And then in here, we'll just say false, or we could clear it either way. Oh, right. I need to. There we go. Okay. So now that should be wired up. I just need something for the enemy to actually detect. We also need some cameras in here, so we'll do a camera 3D. And we'll just bring that back here. There we go. I'll bring that up above it. And let's add a CSG for the ground, just to make this simple. We'll do -0.5, bring that down. And just grab this and move it. And we will set that to a different color. Something less eye bleeding. How's that look through the camera? That looks fine. All right. And now bring that up there. And now we need something for it to actually detect. All this thing is going to detect actually at the moment. So take off monitor roll. It's just going to detect whatever's on layer 1. So we'll just chuck a static collider in here and just say that's the enemy. That's on layer 1. Yep. All right. Add collision node. Or better yet, I will use another CSG for this, and I'll just enable collision on it. So we will do cylinder. Okay, and let's make that bright red, enemy red. And in here, we will turn on use collision. It's on layer 1. That should be fine. Bring this up 1 again. Okay. So now I am going to move that over to here. Let's make sure it's still... Yeah, okay, camera can still see it. And we'll just call this enemy CSG. Oh, okay, that's a little confusing, but whatever. All right, so now this enemy, what I'm going to do is for... This is horrible, but what I'm going to do for simplicity's sake, just to test it, is we're just going to plug an animation player into it. And we will just move it around the screen and just make sure that whenever it gets closer and further away, we'll output some debugging stuff and make sure that the states are transitioning the way they should be. So we'll do a transition track. And I don't know, do 2 seconds, whatever. Insert a key there. Probably ought to pull that a little further back. Where are we at? 7? Okay. All right, and then out in the middle, we'll do, we'll put it there. Is that negative 1.5? We've just done that with the insert keyframe option, but whatever. And we'll set that to loop and set it to the auto load. And we'll just make that cubic to make it nice. There we go. All right, there we go. So we've got that moving around. So now the states don't actually do anything at the moment. So what I'm going to do is have them just print out whenever they change. So we will find, there's my idle state. I'll just put it in the enter method. That way where it's not going to spam it every single frame. And we will just do print idle. And then we'll do the same thing for this combat state. All right. Well, fingers crossed. Let's see how many mistakes I made. Place your bets. Oh, and a crash. What did I do here? Non-existent function, get or else. Yeah, okay. Let's take a look at the blackboard. I did call it get or else. Interesting. State machine dot blackboard. Oh, in base nil. So the blackboard is nil for some reason. Okay. I probably... Oh, okay, not a typo. Oh, yeah, I'm dumb. That's why it's nil, because I never initialized it. That'll do it. I knew there'd be a bug in there somewhere. It never works on the first try. Hey, okay, at least it's moving. That's a good sign. And there we go. Okay, so this is gonna be interesting to show because my OBS setup does not show. I can't capture the game and the Godot editor at the same time. That is a little bit of a problem. So okay, I can see it's working, but let's do something. Let's actually make use of the blackboard to write something back. That's a good example. There it is. This was intentional all along. Definitely not a mistake. Definitely not. So let's make a new, we'll just call this, I don't know, color. So we'll have our color blackboard key. We'll just call it color. And we'll take a reference to that in both of these. And then whenever we change, we will just call this, or sorry, we need to copy it from enemy. There we go. And we will do color blackboard key, and we'll set it to color dot, what is this, idle? I don't know, blue. That's a nice shade. There we go, sky blue. That looks like a good idle color. And we'll copy that and come over into the combat state. And do red. Crimson, that sounds violent. Okay. So now in here, I'm just going to put this in the process. One of the things I thought would be a good idea with the blackboard is to actually give it a signal so that you can detect whenever a specific key you care about changes. But, you know, that's pretty trivial to add. So we'll just make this grab the color directly. So we'll grab the blackboard dot get or else. And again, we'll grab a reference to the key here. Color blackboard key. And we will chuck that in. And we'll just say that the default color is like white or something. And we will just set the modulate. Ooh, that's right. You cannot set modulate directly on a Node 3D. Okay, let me grab some helper code. So in most of my projects, this is a really common thing. Really often, you shouldn't do this. There's some shader compilation issues if you do this, but it's really common whenever you hit an enemy or something like that, you want him to flash red for a second. And because you can't set modulate on a plain Node 3D, it has to be a visual node. But what you really want to do is say every single thing that is visual underneath this node, set its modulate property, which is a really common thing. I have a node utils script that I like to use for that. Oh, wait, is it not in this one? Oh, wow. Wow, one of the few times I actually don't have that one. It must be in Spectarior. Let's see, node utils. There we go. Set material overlay and set material override. So this is one of those copy and paste between every project because you always need it kind of things, which isn't great. I'm not certain, I'm not 100% certain if this is actually what's happening, but with any modern game, and especially with Godot, the shaders need to be compiled, right? The standard material shader in Godot has to get compiled into the low-level code that's going to be sent to your specific graphics driver on your specific OS and all that. So it's got to compile it on your system, and it takes forever to do that. So normally you would preload all your materials, and Godot added a built-in system to try and it's way more complicated than just preloading, and I don't even fully understand it. Something about placeholders that get swapped in and out. It's supposed to preload it if your material is in the scene. So on this mesh instance here, we come up here, and actually I see I didn't give it a material. Okay, we give it a material. I have found that if you edit the modulate property, not of the material, but of this instance, this material override, material overlay, or well, okay, this is the modulate property of 2D nodes. So if we come in here and we do, I think a label has it. I might be mistaken. Does label have it? Yes. Or no, yeah. This property, I have found, if you set this at runtime, it forces a shader recompilation on this shader. This has happened in every single jam game I have done, in Cookie Clamber and Spectarior, anything where I am highlighting an object or doing a damage flash or something. I will often use the modulate property for something, and if the first time you use it, it triggers the shader to recompile and there is a hitch in the game. Now if you change it again after that, it doesn't do it. I think what's happening, if I had to guess, is that behind the scenes, the modulate just isn't used in the shader. It might not even be part of the shader that Godot compiles. And I think the moment you use it for the first time, it makes Godot recompile the shader with the modulate included in the code. I think that's what's happening. At least that's what it seems like what's happening. If you never touch it, nothing happens. The first time you touch it, though, you get a lag spike, and a real nasty one, especially in web exports. So I've gotten to the point where I don't like to touch that anymore. But neither here nor there. What I'm gonna do here, I'm actually gonna edit the material, which is a bad idea. Since we've only got one enemy in the scene, it doesn't matter because it would edit it for every enemy. But I'm just gonna do it for simplicity's sake here. So I'm actually gonna save this material, and we'll call it enemy material. Yeah, whatever. Okay. So now in my code here, I'm actually going to grab a reference to that. And in fact, that actually needs to be a var. I found this out. I didn't know that Godot would actually stop you from editing the properties of a constant, but I found out yesterday it does. I don't know if that's a new thing or if it's always worked that way. I knew you couldn't edit the constant itself, but I learned yesterday that it will not even let you edit a property of one. Okay, so we got that. So we'll do var color here. Color equals that. And then we'll grab this material, which should really just be, it's not what I wanted to do. There we go. That's what I wanted. Albedo color equals color. Okay. So that should work, I think. Oh, it crashed. Blackboard on type. Oh, yeah, that would be wrong. Oops. Kind of surprised I didn't get a warning for that. Okay, it's not working. Let's take a look at the debugger. What are we mad about here? Oh. Let me suppress that just so. Warning, ignore. Unused parameter. I don't like to have these extra warnings hanging around. They make it a lot harder to tell when you've broke something on accident. Okay. So why is that not working? Let me take a look at the enemy script here. First things first, let me try changing this to a different color. That'll tell me if it's actually getting set at all, because the default color on the material is white. So if I see it change to green, then I know it's because this returned null. If it doesn't change at all, then there's probably just something that doesn't work with changing the albedo color at runtime. Okay, and it did change to green. All right, so it is allowing me to set the color, but there's something wrong with reading it that's not working. Did I remember to actually set it in here? I did not. Ha! There's good reason. That's why I should have added the null check in the Blackboard to make sure that this is why you add those things. Even if there's a reasonable default, if I had put in here that if this was null, or if this was null, it throws a warning. So if key does not equal null, do that. Else, push warning. Null blackboard key with value. And we'll do just a %s there, and or no, I guess you have to do there we go. That'll fix that. Hey, it's working. All right. So the Blackboard idea does work. I think it's more subjective at this point, whether or not this is actually an improvement over what I had, or if this is going to be a nightmare wiring up resources. I'm kind of 50-50 on it, to be honest. I think I'm going to have to do a little bit more of an in-depth test. But at least it's an option. And not one I don't think I've seen anybody else do it quite like this before, which maybe is for a good reason, but I'll tell you what, it is getting late, and I think it's best to stop while I'm ahead and before I introduce any more bugs. So if anyone's still here with me, what are you still doing here? Why did you subject yourself to this? And that is going to be it for today. Not sure when I'm going to stream next. I'm trying to stay heads down on the prototype as best I can, but I will post about it whenever I am. And if you're working on your own projects, I wish you the best of luck. Feel free to message me on Blue Sky or Itch or Twitter or wherever you find YouTube, wherever you find me. And I am more than happy to share anything I've learned, or at least tell you what stupid idea I've come up with and why you shouldn't do it either. But that's it. Thanks for watching, and catch you next time.